I'm sure you all know about life of a human. Life of a star is similar to this. Stars are made up of immense amount of hydrogen atoms. Nuclear fusion occurs when 4 of these hydrogen atoms fuse to form a helium nucleus and liberate some energy which diffuses to the outer parts of the star. Due to unimaginably high temperatures at core, helium further fuses to produce carbon, nitrogen and oxygen atoms. Since temperature is insufficient to ignite fusion of carbon atoms, nuclear fusion slows down. The star is now called white dwarf. Since the star gets deprived of energy, the core cools down. If the mass of the star is less than 1.44 solar mass, then the star will remain white dwarf. This limit is called Chandrasekhar Limit. If the mass is higher than Chandrasekhar Limit, then the star will either become a neutron star or a black hole. But how was this limit even calculated? Random motion of particles can't counteract gravitational contraction, due to which white dwarf generally shrinks up to 10,000 km diameter. This suggests that the core keeps contracting, since the density of matter in white dwarf is so high that the thermal or radiation pressure no longer supports the relentless pull of gravity. But what ultimately happens is electron degeneracy pressure acts. To further understand this, Pauli exclusion principle of quantum mechanics states that no two identical spin-half particles can have exactly the same quantum states. This means no such particle can be at the same place at the same time, pointing in the same direction. It doesn't favor the increase in density. Gas is degenerate when all the particles within the gas are packed densely, and self-gravity is counteracted by the electron degeneracy pressure arising from the gas due to Pauli exclusion principle. Electron degeneracy pressure is proportional to density to the power 5 by 3 in non-relativistic regimes. However, Chandrasekhar realized that most of the particles in white dwarf move close to the speed of light, due to which special relativistic effects come in. Relativistic electron degeneracy pressure is proportional to density to the power 4 by 3. This power law dependence on density defines the polytropic equations of state. Pauli exclusion principle of quantum mechanics, electron degeneracy pressure, polytropic equation of state along with special relativity leads to discovery of Chandrasekhar limit, which has been widely used since 1930s.